Well, using taste suppression, we will be able to use one taste to suppress the other so that we can take away some unwanted sensation. On the other hand, sometimes when tastes are put together, both of them would be good, but they also interfere with each other. So the story is about why ice cream doesn't taste as sweet when you've taken it after the chocolate. It is because of a process called sensory adaptation. What sensory adaptation is about is that when we have taken something of a particular sense, after some period of time, you'll find that even though you're exposed to the same kind of sense, you will lose the kind of stimulation and you lost interest in it. They don't taste as well. Now, it is most clearly demonstrated in some of the controlled conditions so that you feed individuals with a particular substance of certain tastes over time, and you ask them to score actually how it is perceived as being rewarding or satisfied. Now, adaptation to one taste, for example, sweetness, bitterness, saltiness, sourness, sometimes we reduce the intensity of taste of the other. Now, usually it occurs when these tastes are of the same category. For example, if you are taking something from the citrus fruit, everything is very sour, and continue to take it for a while. Over time, when you're now drinking something which is sour, you don't find it sour anymore. Sometimes we say that when people try the spicy food, when they keep on taking spicy food for a while, the same kind of spiciness to them, they become less sensitive to it, and you need to demand a higher and higher intensity of the spiciness in order to stimulate the same kind of rewarding response. Now, so that's what happened. In fact, we would say that why is it happening like that? We can easily interpret because when we have sweetness, bitterness, saltiness, or sourness, how are they perceived? They're perceived because they have the receptor on the cell surface, and they would receive all this taste molecule, and once they receive it, they trigger some sort of signal and send out a nerve response and transmit it to the brain. But what happens is that all this receptor on the cell surface, after they bind to the taste molecule, they become internalized. Once they get internalized, they go into the cell. They're no longer on the cell surface. What I mean is that the number of cell receptors on the cell surface is reduced. So of course, you will not be able to give the same kind of stimulation as initially you can. And sometimes it's due to the conformational change because of the binding of all this taste molecule. So essentially, the net outcome is that you would have fewer receptors on the cell surface to perceive the signal. That is one arm of it. On the other arm, think about the spicy food. In fact, it's more than just the desensitization of the receptor. It turns out that when we have all this capsaicin receptor being activated, the cell is being insulted repeatedly. And when you're firing and firing again and again, the cell will simply perceive that it is under stress. And what it leads to is that it would cause the cell to go through necrosis. They would die. So what happens is that if you are tasting spicy food for a long time, in fact, a lot of the cells expressing this particular capsaicin receptor, they are gone. They are no longer there. You have fewer and fewer cells. So no wonder you need to take more spicy food in order to generate the same kind of stimuli that trigger this so-called rewarding response. Now, on the third level, we can also monitor how these cells, in fact, they will respond. In the very the mid-20th century, experiment was done to use some of the taste cells. What do? Is that they take a red tongue and try to simply flush it with constant salty molecules, sweet molecules, sour molecules, or so. And they want to monitor how this cells responds by monitoring the electrical signal being sent out. Here what they have. You'll find that when you initially give this particular tongue cell the sensation of saltiness, sourness, or sweetness, they give a very rapid response, and this is a very strong response. That's how you perceive it. But after a while, when you continue to stimulate again and again, you'll find that the response gradually go down and down and down, and gradually, basically, they don't respond to it anymore. So basically, they are desensitized. And to some extent, that's explain why sensory adaptation is like. And only after some time, if you stimulate again, it doesn't really come up. But if you wait for longer time, then the response will be stronger and stronger again. Why? Because, as I said, a lot of these receptors, they were internalized. But over time, if you don't stimulate them anymore, some of this receptor will be, again, redisplayed on the surface of the cell. So you gain back that response. And if you allow long enough time of like a recovery, they would restore the kind of response normally the tongue cells or would respond to. Now, so that's what happened about this sensory adaptation. Now, when we say that when the tongue is adapted under the so-called control condition, repeatedly bombarding them with a particular taste, a reduction of the other taste quality can sometimes be reduced. Now, understanding this particular principle, it tells you that sometimes if you want a particular taste to be enhanced or reduced, it is not just using the suppressor and enhancer of two different tastes and look at how they interact with each other. In fact, you can start to build up using this sensory adaptation by trying something of the same taste at one point, repeatedly again and again and again. And then later on, if you give them the same dish, which is of the same kind of sense, let's say sweetness. In fact, even though you put a lot more of the sugar in it, they don't sense as sweet as it should be naturally. Okay? So having that, I think we want to summarize what we cover in this particular class. There are a few major elements that we want to focus on. One, we need to understand that taste, sometimes when they get mixed together, they do not give you the same sense as they were given to you individually. You need to understand that. And we have just talked about adaptation, the same sense. If you give it to you again and again and again, the way that you will perceive it is become weaker and weaker and weaker unless you give sufficient time for the recovery. And we also talk about a third element is that, well, you can give you some taste and then later on we subject you to a mixture. Based on this release from suppression, it allows you to perceive the two senses in this mixture very differently depending on what are the prior exposure that you are having. Now, putting all together, it tells us that taste, it seems that we're talking about 5 different tastes and the temperature, high temperature, low temperature. It seems each of them are acting individually. But in reality, when you're eating something, are you simply eating something sweet or something sour or salty? No, they're always a mixture. So you need to understand how to play around with all these tastes to allow them to integrate effectively to give you the perfect match. Having that, that's what we conclude. The temperature effect, whether it's cold or whether it's warm, is going to have impact on the taste of food. And we also show you that mixture of different tastes, sometimes they would interact with each other through suppression. So they kind of reduce the sensation of each other. And we also show that when we are eating something, saliva is also very important because it provides all this buffering and dilution to change the concentration of the food. And at the same time, the saliva allows you to dissolve all this taste molecule and to present them to the sensory cells and to the receptors. So that's how it triggers the kind of taste response. And certainly there are other elements that can bias how you perceive food. For example, we are going to talk about color. How color can be associated with a particular taste. And of course, very importantly, we may not recognize that when we're eating food, we are not just using our tongue. We are not simply sensing the temperature and the taste. When we are masticating the food in our mouth, in fact, some of the food material for the taste and the flavor, some of them actually are volatile. They would go into the retronasal cavity. And what happens is that in that region, in fact, we can smell the food. And a lot of it, we somehow interpret that as taste, but in fact, they are smell. So if we can understand all these different components and we play around with them accordingly to look at the interaction of one taste versus the other, we will be able to prepare a good dish. So to understand that, next time we're going to talk about aroma, how you smell the food, and how the smelling can also be used as a good way to change the perception of the quality of food.